Welcome to another video on how to calculate variances. And again, we'll be looking at direct materials, direct labor, and variable manufacturing overhead. In this video, I will do one of these calculations in a slightly different way, but we get to the same results as we have before on other videos. So here's our scenario. We have some standards that are given to us, and then below that we have actuals. And if you need to write this down, you can always stop, pause the video. However, I have the same information on the following screens. Okay, so the first thing that we do is we look at direct materials price variance. Here we're comparing the actual price to the standard price of direct materials. The actual quantity is the quantity that we're using, so that's going to be the same in both these calculations. 600,000 in a quantity, that's our actual material used, times 283, that gives us $1,700,000. And down below is where I showed how I actually arrived at the 283. We take the $1,700,000 that's given as cost of material, divide by 600,000 actual material used, and that gives us the 283. However, our standard price is $3 given to us in the problem itself. So 600,000 times 3 is 1,800,000. So we actually have a favorable $100,000 variance. The direct materials quantity variance, we're using the standard price, that's the consistent part in these calculations, but the actual quantity is 600,000. That was what was given to us. The standard quantity is 660,000. That's the 220,000 units we actually produced, times the standard of 3 square feet. So 600,000 times 3 is 1,800,000, and 660,000 times 3 is 1,980,000, which gives us a 180,000 favorable variance. These are favorable because our actual price is less than our standard, and our actual quantity that we've used is less than our standard. So that gives us favorable variances all the way across. So our total direct materials spending variance is a favorable variance of 280,000 because that's the net of the 100,000 and the 180,000. And again, we break these down into price variances and quantity variances because sometimes it can swing one way or the other, and the overall spending result could look really favorable or really positive, or actually have a very small variance. But within these, we could actually have big variances. So we want to break them out and look at them separately so that we know how much price is contributing to the spending variance and how much quantity is, or the volume is contributing to the variances. Next, we look at direct labor. In the first part, we're looking at the rate. So we use actual quantity, but then we use the actual rate, compare it to the standard rate. And so our actual rate is the $2 million spent on direct labor divided by the 200,000 labor hours worked. So it gives us a $10 actual rate. So 200,000 hours times 10 gives us $2 million. And the 200,000 hours times the standard rate of 11 gives us $2,200,000. So we have a $200,000 favorable variance there. The direct labor hour or efficiency variance, here we are comparing the actual hours to the standard hours at the standard rate. Our actual hours are 200,000. That was given to us in the problem. Our standard hours, though, is you take the number of units produced times the 1 hour standard. So that's 220,000 hours. So 200,000 times 11 gives us 2,200,000. And the standard hours of 220,000 times 11 gives us 2,420,000. That, again, is a favorable $220,000 variance. Then we net those two together to get the overall spending variance of $420,000. And here's where I do this calculation slightly different, just to show you a different way of looking at it. And you never know which one will actually help you learn it better. Here, what I'm doing is the overhead rate, efficiency, and total spending variance. So since the actual hours are common in the calculations in looking at the differences between the rates, I'm just going to use the actual hours of 200,000 hours. And then look at the standard rate minus the actual rate. So the standard rate was given to us as 50 cents. And the actual rate is 45 cents, and that's calculated by taking the 90,000 variable overhead actual cost and dividing by 200,000 labor hours, and that gives us 45 cents. So the difference between the rates times the actual hours gives us a $10,000 favorable variance because we actually spent less than we thought we would as a per unit rate. Then, in looking at the hours, the efficiency variance, we will take the standard rate as given, which is 50 cents, and then we look at the difference between the standard hours and the actual hours. Our actual hours are 200,000, but our standard hours are 220. That's taking the 220 units produced times 1 hour standard quantity. So the 220,000 minus the 200,000 times that rate gives us a $10,000 favorable variance because we actually use less hours than we thought we would. So we again have overall favorable variances, and when you net those two together, we have an overall $20,000 favorable variance that is over applied. Because we're applying overhead at a rate of 50 cents, we've actually over applied it with this production cycle because it actually should have been applied as 45 cents per unit. So I hope this helps to see a slightly different way of seeing how you could calculate these. And remember, variances, all variances should be investigated. Go with your company's guidance as far as how much money is a threshold. Like I said before on another video, I have worked at companies where $100,000 variances were okay. But above that, you needed to explain it. I've actually worked in one place where a $250,000 variance was okay. And anything above that, you had to explain. So numbers can seemingly be astronomical, but depending on your business, depending on your sector, depending on how much money is flowing through your organization, some of these variance thresholds may be set fairly high. So anyway, if you have any questions about that, please ask below. I'll be happy to help you, and I look forward to seeing you on another video.